evening and good day for everyone. So let's do a few examples on the inverse of Laplace transformation. Okay, before this we have learned how to do the inversion of Laplace transform for elementary function, as well as the inversion of Laplace transform by using your first shift theorem. Okay, so let's do a few exercises. Let's say you have fs equal to -4 over s to the power of 3. So how to find the function ft for this Laplace transformation fs? We just need to see the denominator part, where you can see here your denominator part you have s, a single s, okay, but to the power of more than 1. So this one will directly give you the idea that it might have ft in terms of t to the power of n. Okay, if you can see from the table here, ft t to the power of n is by using this formula, n factorial over sn plus 1. Okay, so when you have s to the power of 3 here, directly you know that your s is actually 2 plus 1. Okay, where your 2 here is your n. So now you have your n is equal to 2. Okay, so you can write your ft as t to the power of 2, but don't forget that you have m in front of this one. So how to find the value of m? You need to times m with the one in the numerator of your formula, which is n factorial, must be equal to the one that you have in your function here. Okay, so it's equal to -4. So you have your n is equal to 2, therefore here you have m times with 2 factorial is equal to -4. So 2m is equal to -4, therefore your m is equal to -2. Okay, so your final answer for your ft is equal to -2 t to the power of 2.
Okay, so let's see. Okay guys, so let's see one example here. You have fs equal to 6 over -2s plus 3. So we want to find the inverse Laplace transformation of this function. As we know that before this, if we have ft, okay, if we have ft, we will do a process of Laplace transformation to get fs. Okay, now we have fs, we want to get back what is our ft, so we will do the process of inverse Laplace transformation. Okay, so now we want to do the process of inverse Laplace transformation on fs, where fs is equal to 6 over -2s plus 3. So how to do the process of Laplace inverse transformation? You need to see in the denominator part. Okay, if you see the denominator part, you have only the single variable s, therefore you know this one will related to the constant. Okay, if you have in denominator s to the power of more than 1, but you have a single s here, but the power is more than 1, okay, so this one is related to the ft equal to t to the power of n, because you have in the denominator here sn to the power of n plus s to the power of n plus 1. Okay, if you have in the denominator in the form of s together with any constant, either plus or minus, okay, so this one will be related to the exponent, but the one in the numerator must be any constant c. Okay, so the one in the numerator must be any constant, and you have single s together with plus or minus a constant a. Okay, so this one will be related to the function exponent at. Okay, if you have in the denominator s squared plus or minus any constant, okay, if in the numerator is a constant c, so this one will be related either to the sine at or sine hyperbolic at, okay, because you have the denominator s squared. If you have the denominator s squared plus minus a, but in the numerator you have s, okay, this one will be related either for cos and also cos hyperbolic. Okay, if you have the fs equal to exponent function over s, then it will be related to the unit step function, but if you have the singular exponent function, it will be related to delta. So this is how you want to compare how to get your ft from the table of Laplace transformation. Okay, so now what you have here in your equation fs is 6 over negative 2s plus 3. So you can see that you have the single s with the constant here, but then if you compare to the form of Laplace transform for exponent, your s must have coefficient equal to 1. Therefore, you need to do some modification in the numerator so that your s only have a coefficient 1. Okay, so what we will do is we will divide by negative 2. So you can rewrite your fs as 6, or you can take out negative 2, so you can divide your fs as 6 over, take out negative 2 outside, so what you will have here is s plus will become minus because you take out the negative sign. Therefore you have s minus 3 over 2. Okay, because you factor out the negative 2, therefore here you have negative sign. Okay, now this one will become a constant where 6 over negative 2 will give you negative 3. Therefore, you can write your fs as negative 3 over s minus 3 over 2. So directly you know that this one is your A because you compare your A with this one, okay, this form. So it will give you your ft equal to exponent at. So your a now is 3 over 2, therefore you have exponent 3 over 2t. But don't forget that you have m in front of your function here. So how to find m? You just need to see the numerator. If you have 1 here, therefore your m times with 1 equal to whatever numerator that you have in your function, negative 3. Therefore, your m is equal to negative 3. So your final answer ft is equal to negative 3 exponent 3 over 2 t.
S equal to 7 over 2s plus 8. Okay, we want to find the inverse Laplace transform of this one to get what is the ft. Okay, so you need to see in the denominator. So here in the denominator you have the s to the power of 1, but here you have a constant together with s. Okay, so when you have this kind of function, you can see that it's closer to the form of exponent at. But what you can notice here is your s in this function cannot have coefficient, or the coefficient is equal to 1. Therefore, you need to factorize out 2 so that your s now is with the coefficient 1. So you can rewrite your equation as fs equal to 7 over, factorize out 2, so what you have here is s plus 4. Okay, so 7 over 2 here is just a constant. You can also write it as fs equal to 7 over 2 1 over s plus 4. Okay, it will be easier for you to see. Okay, so 1 over s plus 4 is actually closer to this form of exponent at, but if you can notice here, your sign is negative. Okay, so you can rewrite this as fs equal to 7 over 2 1 over s minus 4. Okay, so directly you can see that minus 4 here is your a. Okay, so minus 4 here is your a. Therefore, you can write your ft as 7 over 2 as a constant in front, exponent at, so your a is negative 4, therefore you have exponent negative 40. So this one is your function ft. Okay, how if you have your fs equal to 12 over s squared plus exponent negative 9s? So you can find the inverse of Laplace transformation here separately. Okay, the first thing is to find what is the inverse Laplace for 12 over s squared. Okay, so you can see that in your denominator you have s to the power more than 1. Therefore, directly you know that this one is related to this function where you will have your ft in the form of t to the power of n. And this one can rewrite as 12 over s1 plus 1. Therefore, you know that your n is equal to 1. Okay, so ft for this one is t to the power of 1, but don't forget that you have m in front here. So how to find m in front here is m times with the formula, and factorial is equal to whatever you have in your function 12. So your n is equal to 1, so 1 factorial is 1, therefore 1 times m is m is equal to 12. Okay, therefore what you will have here is 12t to the power of 1. So next one, you have here the exponent negative 9s, and if you compare to the table, the exponent negative 9s is actually related to the function of delta t minus d. Okay, where delta t minus d, the Laplace transformation of this function, will give you exponent negative ds. So what you need to know is what is your value of d. Okay, so directly from here you know that your value of d is 9. Okay, because you have negative here, here is negative, you have s here, here is s, so your d is equal to 9. Therefore your function ft for this exponent 9s is actually delta t minus d. Your d is equal to 9. So therefore you have 12t plus delta t minus 9. So this one is the function ft. Okay, now you have function fs equal to s plus 2 over s plus 1 to the power of 2 plus 1. Okay, so you can see that in your denominator you are not have the single s, but then s here is together with the constant positive 1. Okay, so this one is not the elementary function for the inverse Laplace, but you need to use the first shift theorem. Okay, to use first shift theorem, you need to make sure that every s has the same constant, but the one in the numerator here is s plus 2, so you need to rewrite this one so that it will be s plus 1. Okay, so how to rewrite this one? What you want is s plus 1. Okay, but what you have is s plus 2. Okay, so how can you do for your s plus 1 to be s plus 2? Okay, your s plus 1 must be plus with another 1. Okay, so that you will have s plus 2. When you open the bracket, it will be s plus 2. Means that your s plus 2 in the numerator here can also be written in the form like this. Okay, so if I rewrite, I will have fs equal to s plus 1 over s plus 1 square plus 1. Okay, now if you can see, we have the two terms in denominator, so we can separate them. Okay, we have the first term here is s plus 1 and the second term here is plus 1. Therefore, if you separate, what you will have here is fs equal to s plus 1 over s plus 1 square plus 1 plus with 1 over s plus 1 square plus 1. Okay, so let's solve this one by one. First, we want to solve the one here in the bracket here. Okay, so we have s plus 1 over s plus 1 square plus 1. If you can see in the denominator, your s now is not a single s, but it's together with the constant positive 1 here. Okay, so you need to use the first shift theorem, but by using the first shift theorem, you have in the form of fs minus a. Okay, therefore you need to change the sign from positive to negative, so you can rewrite this one as fs equal to s minus negative 1 here. So you have s plus 1 over with s minus negative 1 square plus 1. Okay, same to this one, you will have 1 over s minus negative 1 square plus 1. Okay, so now by using first shift theorem, we know that this negative 1 is actually our a. Okay, this negative 1 is actually our a, so we just take note that our a is equal to negative 1 here. Therefore, after you take note, you can just ignore and eliminate negative 1 from this function. So what you left here is only s over s square plus 1. Okay, so if you see in the table, s over s square is related to the cos of cos hyperbolic. Okay, so you need to see the sign. The sign here is plus, therefore it's related to cos 80. So what is your a? Your a must be in the form of uniform of a square. Therefore here is you have 1 square, so your a is equal to 1. This one is a for cos, this one is a for exponent. Okay, don't get it wrong. So now what you have as your ft is cos 1t. So you have cos t. Okay, so this one is the first one. You need to plus with this one. This one also you have a equal to -1. So when we know already our a, so we can just ignore the a here. So you can rewrite your equation as 1 over s squared plus 1. So when you have s squared plus some constant in the denominator, but you have constant in the numerator, it's related to this one. S squared plus constant, and the numerator is constant. Therefore, this one is can be write in the form of sine 80. So what is your a? A is here 1. Okay, therefore you have here sine 1 times t is sine t. Okay. Then don't forget that this one is not the final answer, because all of this you need to times with the exponent at, since we are using the first shift theorem. So exponent at, your a is equal to -1, therefore you have exponent -t cos t plus sin t. This one is your final answer.
See how to solve this fs. We want to find the inverse Laplace for this function fs equal to s minus 6, s minus 4. Okay, so if you can see in the denominator, okay, you have the single s with the constant here. So this one is actually related to the function exponent at. But then if it's exponent at, you must have a constant in your numerator, but now you have s in your numerator. So you cannot use the exponent at as your ft. Therefore, we cannot use the table to get the function ft for this fs. So we can use the first shift theorem. Okay, so the first shift theorem, if you want to use the first shift theorem, the constant together with s must be same in the denominator or in the numerator. So now in the denominator you have s minus 4, but in the numerator you have s minus 6. You need to do some modification in this fraction so that it will be same. So the numerator will follow the denominator. So what we have in denominator is s minus 4. Therefore, we also want s minus 4 to be in the numerator. Okay, so we want s minus 4 to be in the numerator. But now your numerator is equal to s minus 6. So how from s minus 4 you want to get s minus 6 is by minus with 2, right? Because when you open the bracket, s minus 4 minus 2 is equal to s minus 6. So in the other words, s minus 6 can also be written as this equation, s minus 4 minus 2. Therefore, let's replace on the numerator. So now you have your fs equal to s minus 4 minus 2 over s minus 4. S equal to s minus 4 minus 2 over s minus 4. We can see that now our s is together with the constant -4. So we just note that our a is -4. Okay. So after you note that your a is -4, you just can ignore the -4 here. So you can rewrite your fraction as fs equal to s minus 2 over s. Okay, so this one you have two different numerator you have two different terms in your numerator, so let's make them a separate fraction. So you can rewrite your fs as fs equal to s over s minus with 2 over s. Okay, and s over s is equal to 1. So you have your fs equal to 1 minus 2 over s. Okay, if you compare to the table here, if your fs is equal to 1, means you have the function ft equal to delta t. So directly this one is delta t. Okay, minus with, if you have your fs equal to 2 over s, with the denominator consists of a single s, so you know this one is related to the constant a here. Therefore, your a is equal to 2 directly. Okay, so you have delta t minus 2. Okay, don't forget that your ft must be times with exponent, since we already take out the value of a here. Therefore, this one, everything will times with exponent at. Your a is -4, therefore you have negative exponent -4t times with delta t minus 2. This one is your ft.
Okay, how if you have fs equal to 9 over s minus 3 squared? So if we compare to the table here, we cannot see any function that related to this form of fraction. Okay, because in the bracket you have s minus 3 to the power of 2. So if you cannot find in the table, you might use the first shift theorem. When you use the first shift theorem, whatever that stay with your s in the denominator will be a. Okay, so here you have your a is equal to 3, because we always have the function fs minus a in the first shift theorem. So whatever stay with s is a, okay, with minus sign here. So here directly your a is equal to 3, just put note here a is equal to 3. So now when you already know that this one is your value of a, so we can just ignore this part. Okay, so we can rewrite our function here as fs equal to 9 over s to the power of 2. Okay, so now you can see that in your denominator you have s to the power more than 1, therefore this one is related to the function here, okay, which will give you the ft equal to t to the power of n. So here if you can see in denominator s is to the power of n plus 1, so let's rewrite our fs. So our fs is equal to 9 over s to the power of 1 plus 1, so directly you know that your n is equal to 1. Okay, so this will give you the function ft is equal to t to the power of 1, but don't forget you have m in front here. So how to find m? To find m, you just write m. Okay, to find m, you just need to write m times with the numerator in formula here, so n factorial will equal to whatever you have in the numerator for your function, 9. Okay, and you know that your n is equal to 1, therefore m times with 1 factorial is equal to 9. 1 factorial is equal to 1, therefore m is equal to 9. So you have your ft equal to 9t to the power of 1, or 9t. Okay, don't forget that before this you have take out the value of a, and this value of a will create exponent function in front of your function here, therefore you will have your final answer ft equal to exponent at, so exponent 3t times with 9. So this one is your answer. For example, here you have fs equal to s minus 7 over s minus 2 to the power of 2 plus 1. Okay, so this one cannot be compared in any elementary function on the table, because with s in the denominator you have a constant negative 2. Okay, means that this one is can be solved by using the first shift theorem. When you want to use the first shift theorem, you need to make sure the constant together with the s here must be same in the denominator as well as in the numerator. But now in the denominator you have s minus 2, but in the numerator you have s minus 7. So you need to do some modification here. Okay, so what we want, our numerator must follow the denominator, so what we want here is s minus 2 to be in the numerator, but what you have in your numerator is s minus 7. So how s minus 2 need to do to s minus 2 so that it will become s minus 7 is minus with 5, right? Because when you open the bracket, s minus 2 minus 5 is equal to minus 7. So in the other words, s minus 7 can be rewrite or can be write as this equation. Okay, so let's replace it in our numerator. So we will have our fs equal to s minus 2 minus with 5 over s minus 2 square plus with 1. So now directly you can see that you have constant negative 2 together with your s, so this one will be your a. Okay, because the first shift theorem will have the form of fs minus a, so your a will be after the minus sign. So here is your a. Okay, so your a is equal to 2. Just take note that a is equal to 2. Later a will give you the function exponent at, which is exponent 2t. Okay, so when we already take the value of a here, we can just ignore the negative 2 here. So let's rewrite our fs. We have our fs now equal to s minus 5 over s square plus 1. So now you have two different numerator here. Okay, so let's make them to be a different fraction. So what you will have here is fs equal to s over s square plus 1 minus with 5 over
s square plus 1. So now you can see that in denominator you have s square plus with any constant, and in your numerator you have s. So this one is close to the function of cos. Okay, because you have plus here, therefore it will be a cos 80. So now your a must be in the form of a square. So let's rewrite our function here. We will have s over s square plus a square. So a square is equal to 1 square. Okay, 1 square is equal to 1, so there's no problem here. Directly, you can see that your a is equal to 1. This one is your a. Okay, so this function fs will give you the ft equal to cos 80. So cos, your a is 1, so cos 1t. So cos t. Okay, but in the fraction here, you also have s square plus 1, so you can write as s square plus 1 square, but you have a constant 5 in your numerator. So when you have constant, so it will related to the function sine. Okay, a over s square plus a square. So here the sign is plus, therefore it will be related to sine 80. So now your a is equal to this one. Okay, so you have minus sine 80 here, but because you have minus sine 80, your a is equal to 1, therefore you have minus sine 1 times t is sine t. Don't forget that you have m in front here. Why we have m in front here? Because in the numerator we don't have a constant a. Okay, we must have a in our numerator, because in the formula you have a here and you have a in the numerator, but now you have your a is equal to 1, but you know your numerator is not equal to 1. Therefore you will have a constant m in front of your sine t. So how to find what is the value of m? M times with the one in the formula, which is a. M times with a, you will get whatever you have in your function numerator here, which is 5. Okay, so now you know that your a is equal to 1, therefore you have m times with 1 equal to 5, so your m is equal to 5. Therefore your final ft for this one is ft equal to cos t minus 5 sin t. Don't forget that just now you take out the value of a equal to 2, which will give you the exponent 2t. So ft is actually the exponent 2t times with cos t minus 5 sin t. So this one is your answer.